The National Map is a collection of mapping products and services produced by the USGS National Geospatial Program. The products and services are accessed via the Internet through service calls and graphical user interfaces. The National Geospatial Program has released a series of how-to videos for people who are working with the National Map data and services. The videos show how to use the services and interfaces to access data and tools for viewing, analyzing, and printing geospatial data. Lessons 1 and 2 serve as an introduction to the training materials, and the remaining how-to videos may be viewed as needed in any order, depending on the user. Any use of trade, product, or firm names is for descriptive purposes only and does not imply endorsement by the U.S. government. Lesson 10b2, Exploring and Classifying Lidar Data in ArcGIS Pro. Lesson 10b1 introduced the basics of interacting with Lidar point cloud data in ArcGIS Pro. This lesson will cover additional Lidar point cloud processing and analysis features in ArcGIS Pro. If necessary, please review Lesson 10b1 for guidance with importing LAS files, filtering, and visualizing Lidar point cloud data in ArcGIS Pro. By the end of this lesson, you will be able to view LAS classes, select points to reclassify using polygon selection and class filtering, edit LAS classes with manual and automatic classification methods, and understand the fundamental difference of a LAS file and a LAS dataset. In this tutorial, we are using uncompressed LAS data. ArcGIS Pro does not have the ability to natively read LAS files, but there is an interoperability extension in the ArcGIS environment that can convert LAS to LAS for additional cost. Please refer to Lesson 10E2 on how to convert LAS files into LAS files for free. If you're interested in learning more about using ArcGIS LiDAR data in other software packages, additional videos show how to use LiDAR data in Global Mapper and LP360. For this lesson, we will be using the same tiles of LAS data from Lesson 10b1. If you've not done so already, please download the USGS LPC CO SoPlat River data for lessons.zip file from our FTP site at rockyftp.cr.usgs.gov/training_data. Note that Google Chrome no longer supports FTP, so you will need to enter this link into a File Explorer search bar and navigate to the folder, or use Microsoft Internet Explorer to access the data. After you've downloaded the LiDAR data, extract the zip file into a folder on your local computer to use during this lesson. The National Map has a download client where you can find USGS products including elevation data such as LiDAR point clouds at apps.nationalmap.gov/downloader. If you are interested in learning more about downloading products on the National Map, be sure to check out our training videos located at www.usgs.gov/ngp videos. To begin, open ArcGIS Pro on your computer. This exercise specifically uses ArcGIS Pro version 2.5. However, any version 2.1 or newer should suffice for this tutorial, but there may be a few interface and layout differences from version 2.5. Use your enterprise or personal login information if prompted by the ArcGIS Pro login prompt. Once you have successfully logged in, click the Map tab under New Blank Templates. In the Create a New Project window, name the project ArcGIS Pro LiDAR Training Lesson 2. Use the same folder we downloaded the LiDAR data to in the previous lesson 10b1. Then click OK. On the Map tab in the Layer ribbon, select the Add Data icon. In the Add Data window, browse to the location of the LiDAR point cloud LAS files that were downloaded from the FTP site. Click on the file name ending in 13SDD483396 LAS 2015 and click OK. The map extent is zoomed out too far, so none of the points are able to draw. The red box shows the extent of the LiDAR point cloud data. To see the point cloud data, zoom in or type 1 to 2000 in the map scale box in the lower left corner of the map. The map now shows the point cloud data colored by elevation, which is shown by expanding the last layer dropdown in the table of contents. At this scale of 1 to 2000, only 10 to 15% of points are being drawn. This will vary based on your screen size. If you've not already, highlight the last layer in the table of contents by clicking it once. Now that the layer is activated, click the Appearance tab and select the Symbology dropdown and choose Class under the Symbolize Your Layer Using Points heading. In the Symbology pane that has appeared under the Draw Using dropdown, make sure it says Classification and the Draw Using box is checked. Read through the legend to see the various classes listed in the Table of Contents legend for the last layer. These classes include Ground, Low Vegetation, Medium Vegetation, Noise, Overlap, and High Noise. Close the Symbology pane when you're finished. Next, we will explore how ArcGIS Pro stores metadata for LAS files. Right-click the LAS layer and select Properties. If you select Metadata, you will notice there is no information for this layer. Now click the Source tab. This tab shows the file locations, number of LAS points, and vertical units all sorted under the Data Source dropdown. Expand the Spatial Reference dropdown. This shows the projected coordinate system NAD 1983 UTM Zone 13N and vertical coordinate system NAVD 88 Geoid 12A meters. On the Layer Properties dialog box, select the LAS Filter tab and explore the classification codes. Unfortunately, all the codes listed pertain to the ASPRS LAS version 1.4, which do not pertain to this particular file's LAS version. All classification codes are defined by the American Society for Photogrammetry and Remote Sensing, or ASPRS, for LAS formats 1.1 through 1.4. Each version has changes to the class numbers and classification of certain criteria, as we will discover later. In order to verify the LAS version of these LAS files, we must access the vendor report to verify the LAS version. As a part of the USGS 3DEP project, various contractors are hired to collect and deliver Lidar data to the USGS. Vendor reports are required with every contract of the Lidar missions. For this tutorial, we have accessed the vendor report from the same FTP site where the data was downloaded, in order to observe the LAS version and metadata information. Under the Deliverables section of this vendor report, the uncalibrated, unclassified raw point cloud swath is listed as LAS version 1.2. The vendor report has been accessed in advance for reference. Now that we know the LAS version is ASPRS version 1.2 format, we will compare the ASPRS LAS data versions 1.2 and 1.4 and note some of their differences. The American Society for Photogrammetry and Remote Sensing periodically updates the LAS file format, including changes to point classes. For information about the current LAS file version, please see the LAS Specifications version 1.4-R15 document found at the ASPRS link shown here. As you can see, in LAS version 1.2, the classes highlighted in blue were reserved but not yet defined. But by LAS version 1.4, many of these previously reserved classes were defined. For example, in LAS version 1.2, Class 17 is reserved, and by version 1.4 it is defined as Bridge Deck, and so on. The acquisition vendor used some of these reserved classes, and they do not depict the correct features in LAS 1.4. For example, Class 18 was used for overlap ground points instead of high noise. This is shown in the vendor's Airborne Topographic Lidar report. Note the classification scheme for Class 17 as Overlap Default, and Class 18 classified as Overlap Bare Earth by the vendors. However, if you go back to the Properties window and select LAS Files Filter again, the default classification reads LAS Files as version 1.4. If the LAS Filter window is not currently pulled up, make sure the LAS file is selected in the Table of Contents and select the Appearance tab on the ribbon menu. Then click the LAS Points icon. Make sure to select the icon and not the drop-down arrow. This will open the LAS Layer Properties window. Uncheck the All box to turn off all classes. Then check the Class 17 Bridge Deck to turn it on. Then click OK. With the LAS filter, you can see that the LiDAR collection used Class 17 to classify points within the overlap between flight lines. This explains the reason for some of the classification discrepancy. Now we'll visualize some of the other point classifications. Open the last layer properties by clicking on the last filter window under the Appearance tab of the last dataset layer ribbon, and click on the top icon, not the drop-down arrow. Again, if the All box is checked for the classification codes, click it again to deselect all classes to turn them off. Check only the to ground classification code for the list, then click OK. We will now view our ground surface in a 3D scene. To do this, we must create a separate 3D map window or local scene. Navigate to the View tab and select the Convert icon in the drop-down. Select to Local Scene. In the local 3D scene, click the top icon of the Symbology button under the Appearance tab and make sure the Symbolize Layer by Using Points icon is selected and that Draw Using Elevation is selected. If the Draw Using box is checked and the layer has not shown up in the 3D scene, check the Draw Using box to turn it off, then check it once more to draw the layer again. The layer should draw immediately after checking the Draw Using box. Because the file is so large, it may take a while for the last point cloud to draw completely. We will convert the last file to a last dataset to better improve the functionality of the processing and viewing in ArcGIS Pro. A last dataset is designed to use Lidar data in LAS or compressed LAS file types. It supports any LAS file version 1 through 1.4. It is important to note that the LAS format supports the classification codes for each point according to the American Society for Photogrammetry and Remote Sensing, and ArcGIS applies the class codes specified for LAS version 1.4. A LAS dataset has the capability to store and reference many LAS files, compiling them to one LAS dataset, similar to a mosaic of raster surfaces. The LAS dataset enables the user to view the LAS file or files in their native binary format of stored airborne LiDAR data. By using a LAS dataset, users can more efficiently conduct QA/QC on LiDAR data and quickly visualize many LAS files at once, as either a TIN or point cloud, in both 2D and 3D views. The LAS dataset also allows the user to manually fix or reclassify errors in class codes through editing techniques provided by ArcGIS Pro. We will cover more on LAS datasets in another video. For more information on what a LAS dataset is or LAS dataset capabilities and properties, visit these ArcGIS Pro help pages. Select the Tools icon in the Analysis tab. In the Geoprocessing search window, type Create LAS Datasets. Then select the option to create LAS dataset. In the Input Files section, browse to the folder containing your downloaded LiDAR data and select the file ending in 13sDD483396_LAS_2015.las. Then click OK. In the Output LAS Dataset section, browse to your project folder and name the LAS dataset tutorial_10b2.lasd. We will not be working with the clipping, extents, or break lines for the LAS dataset in this tutorial, so leave the surface constraints blank. Verify that the coordinate system corresponds to your original LAS file. This can be found by right-clicking on the original .las file and selecting Properties, then Source, and expand the Spatial Reference drop-down arrow. In the Geoprocessing window, if the coordinate system does not read NAD 1983 UTM Zone 13N /VCS NAVD 88, then select the appropriate projections and coordinate systems. Alternately, you may select the original LAS file from the coordinate system drop-down menu, and it will automatically choose the LAS file's datum and projections. Make sure Compute Statistics is checked, then click Run. Now is a good time to save your project. Go to the upper left corner and select the Save icon, or hit Ctrl+S. Turn off the last layer ending in 13sDD483396_LAS_2015. Make sure the last dataset layer, tutorial_10b2, is highlighted by left-clicking it once. Right-click the tutorial_10b2.last layer and select Properties. In the Last Filter tab under Classification Codes, check All to deselect all classes, and then check the 11 road surface and 2 ground boxes to add them to the display. Notice the floating red points that are classified as road surface. If you are using a mouse, the left mouse button will allow you to pan around the map view window. Click and hold the middle mouse button to rotate the 3D scene to view the point cloud from the side, and click and hold the right mouse button while moving the mouse to control the zoom. If you are using a laptop pad without a mouse, access the on-screen navigator tool to control the tilt, pan, north orientation, and rotation around a target as shown in the slide. For more information for the on-screen navigator tool, visit this link. There are also very helpful keyboard shortcuts that can be found here. Under the Map tab, make sure the Explore tool is highlighted. In the Map Extent window, click and hold the middle mouse button to rotate the 3D scene to view the point cloud from the side. Click and hold the left mouse button to pan the scene, and click and hold the right mouse button while moving the mouse to control the zoom. If you are not using a mouse or have a laptop touchpad, access the on-screen navigator tool and select the full navigation drop-down arrow on the screen. Click the Last Points button again to view the last filter properties. Turn off the 2 ground classification and add the 18 high noise classification to the view. The high noise classification appears to be ground points in areas of swath overlap, whereas the road surface classification points appear to be actual high noise points. Next, let's visualize Class 17. Check the 17 bridge deck points classification and turn off all other classes. The points classified as bridge deck appear to be buildings, vegetation, and roads in areas of swath overlap. From visualizing these classifications independently, we can see that there are some misclassifications within the dataset. While there may appear to be large mistakes in classification, remember that these project data were delivered in LAS format version 1.2, whereas the LAS version used by this software is currently version 1.4. Now that we have identified some misclassifications within the dataset, we can modify them. ArcGIS Pro provides several automatic and manual classification tools to edit and classify LAS classes. The LAS dataset is just like a mosaic dataset. It stores the Lidar footprint and statistics, but it is referencing the original LAS files. So when we modify the codes, we will be changing the original data. If you look in Windows Explorer, you'll see the LAS dataset is only 7 kilobytes, and the date modified for your fixed LAS file will be more recent than the other 5 tiles. In case of any errors in reclassifying, we will create a copy of the LAS file in order to keep an original backup. In the Geoprocessing pane, search Copy and select the Copy Data Management tool. For the input, select the LAS file ending in 13 sdd483396_las_2015.las by navigating to the folder containing your downloaded Lidar. Name the output file the same as the original LAS file, but add _copy.las at the end of the file name. Because the points have been previously classified, we will change the classification codes using the Reassign Classification tool located in the Classification tab in the top left corner. We will start by reclassifying the misclassified high noise points into the corresponding 12 overlap points, filtering the point cloud to only display the 18 high noise classes we did previously. Select the Classification tab and click the Reassign Classification button. This will open the Change LAS Class Code Geoprocessing pane. Input the current class as 18 for the high noise points that are turned on, and set the new class to 12 for overlap points. Accept the defaults No Change. Click Run. A red box will appear over the extent showing no points in the current LAS point filter because we have reassigned class 18. Next, change the LAS filter to only show 11 road surface, Using the Reassign Classification tool, which should still be open in your geoprocessing window, repeat the same procedure for input Class 11 and new Class 18. This will change the high noise points in Class 11 roads to high noise points in the correct high noise point Class 18. To view the new classifications, go to the last filter and select only Class 18 high noise. Now we will repeat the same process again for Class 17 bridge deck. Change the filter to only show Class 17 bridge deck. Click the Reassign Classification and input 17 for current class and 12 for the new class, in order to reclassify these overlapping above ground points into Class 12 overlap. Click Run. ArcGIS Pro also offers some automated classification tools. We will now classify buildings using the Automated Classification tool located to the right of the Reassign Classification tool. Click on the Automated Classification drop-down arrow and select Classify Buildings. Make sure the input last dataset reads tutorial_10b2_copy.lasd. Change the minimum rooftop height to 4 feet and minimum area to 5 square feet. Make sure Compute Statistics is checked and the other boxes are not, then click Run. Once the tool has finished running, filter only Class 6 buildings and zoom in to see the building filter. You may change the base map to imagery to better delineate the building footprints. After viewing the buildings, right-click the tutorial_10b2.lasd layer and select Zoom to Layer. There is a light green bridge or overpass classified as a building. It's located in the right central edge of the point cloud. We will manually zoom in and select these points and reclassify them as 17 bridge deck. Go to the Classification tab under the Last Dataset layer ribbon and select the Select Last Points by Rectangle tool in the Selection section. Draw a rectangle around all points in the bridge feature by left-clicking and dragging the mouse to draw a rectangle. The initial selection will not select all the points, so you may need to zoom in and hold the Shift key and repeat the Select by Rectangle multiple times to select all points in the bridge. The total points should be around 4,000. Once all the bridge points are selected, click the Classification Code drop-down arrow and choose 17 Bridge Deck. Click the highlighted arrow labeled Apply Changes. The points should disappear from our filtered extent. Go to the Last Points filter and choose only 17 Bridge Deck. The bridge we just manually reclassified should draw. Congratulations, you finished Lesson 10b2, Exploring and Classifying Lidar Data in ArcGIS Pro. In this lesson, we discussed how to view last class codes, select points of interest using polygon selection and class filtering, use manual and auto classification methods to edit last classes in a last dataset, and how to generate and use a last dataset. If you are interested in learning more about using LiDAR data, please see the additional USGS LiDAR training videos in ArcGIS Pro, LP360, and Global Mapper at www.usgs.gov/ngp videos.